Right. So SQL Server, so using a normal priority, so that is your 7. So 7 is not a specific priority. It is kind of a range of, priorities that we allocate, but SQL is using a normal priority that is, so equal to 7. Right. So if you work on any deadlock issue, then you set low deadlock priority to low something, right? So that is, this is one of the configuration that we set uh, to avoid deadlock situations, right? So that is there, like, so that is what we call it as a priority. When high priority thread comes in, the thread which is currently executing on the CPU will come out of CPU and will let other thread to execute. So this is mainly controlled by the operating system. As I told you, whatever quantum slicing and all, right? So that is an operating system concept. Operating system will decide how much time a thread which is currently executed on the CPU has to run, and whether if there is any high priority threads are coming in, then it should be kicked out of CPU, right? So that is scheduled by the Windows operating system. Right. So this is the minimum work required for the user code. Right. So we no need to worry much, because you'll have to, so keep on running on the CPU. See, Windows operating system will decide when to run on the CPU and when to kick out of CPU. So Windows operating system will decide. Right. Context switch, we already discussed about context switching. So whenever the thread come out of CPU, the thread information will be saved in a place, right? So in a place it will be saved. Whenever a thread again wants to run on the CPU, it should start from where it left. So what happens if too much context switching? So we will discuss that. So this is a main core thread states that we have. One is waiting, ready, running. So what is that waiting, ready, running? This is again, like I'm talking about Windows sense, even SQL Server also the same way we have, right? What is the thread states that we have? Okay, right. So waiting, let's say for example, I have a thread which is currently running, right? So that is on the CPU. We call that as a running CPU. And that thread needs some resources, right? For example, a thread which is running needs some resources. Let's say for example, it has lock. Yeah, I mean it needs a resource to execute its execution, so it has to wait on lock, right? It has to wait on some resources. Lock is one of the wait resource, right? So it is waiting on lock to be released by another thread which is holding. So we will talk about that. Or it is waiting for anything, right? You must have heard like wait types, right? So let's consider that it is waiting on any resources, or the thread needs to wait on some resources. Then it should go out of this running thread, out of this CPU, and it will be waiting on the waiter queue, right? You can consider this as a queue, right? So it is waiting on the waiter queue. Once the waiting is done, once this has the resource it needs, then it will go and waiting in the ready queue. So it tells that I'm ready whenever CPU is available, right? So if it is come out of CPU, it has to come out of CPU, right? We are not running. So we are waiting for some resources. If that is the case, we cannot keep on waiting on the CPU. It should come out of CPU and let other threads to execute on the CPU. Then the thread, once the resources are acquired, then the thread will be in the ready queue telling that I'm ready to run on the CPU, right? So we will talk more So we will talk more when we talk about SQL schedulers and SQL uh, queue states, right? So we have some queue states, right? So this is what we already discussed, when this will become out of CPU, when the threads will be scheduled. So voluntarily yield. So when this voluntarily yield, so when the thread come out of CPU on its own, right? Once the thread completed its execution, right? Within 4 milliseconds, the thread is completed its execution. Then it should come out of CPU, or the thread needs some resources to proceed further, right? If the thread needs some resources to proceed further, then it should come out of CPU on its own, right? Or preempted. Preempted is nothing but a high priority thread comes in, the current executing thread will be get out of CPU. Quantum ends that we discussed, 4 millisecond ends, it will come out of CPU. And termination, so the thread will be terminated if it is keep on running, so then it will be terminated by the operating system. Or if the thread is idle for some duration, then the thread will be terminated, right? So yeah, then what is the main purpose that we have UMS? So until this point we have, right, everything is working fine. Why we need UMS? What is UMS? Why we need UMS? So UMS is nothing but user mode scheduling, right? So until we discussed till now the Windows level scheduling, how that works, when the thread will be scheduled on the CPU, when the thread will come out of CPU, so that will be taken care by the Windows operating system. So why we need our own scheduler to execute
Chandu,
CPU?
Chandu, can you repeat? Can you, also, sorry for the interruption.
Hmm,
So till now we have spoke all under CPU related, right?
correct. Windows related scheduling.
Okay, 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 Chandu.
Yeah. So what is your question? So I mean, so concept wise, we will have some layer, like, so we will be discussing a few related to Windows and SQL Server. But what is your question, right? So till now we discussed about the scheduling, the basic scheduling, how that works,
Okay,
right?
okay, Chandu.
Cool. Okay. So the design goal that we have for UMS, user mode schedulers, why we need sec, right? So it's not going. Fine. So UMS goal, why we have another layer between so why we need our own scheduling mechanism to implement our scheduling of threads, right? So control the main goal of UMS, right? So control which thread should run from the SQL CPU. Let's consider if we don't have a Windows scheduler. So if we don't have so SQL Server, our own scheduler, let's say, for example, I have 100 threads. So I have 100 threads, but I have only 4 CPUs. 1, 2, 3, 4, right? So if I have 100 threads, and if we have 4 CPUs, I told you, right, it will be distributed in a round robin, one after another. Let's consider 25 threads is allocated here, and 25 threads, 25 threads, and 25 threads. All threads are exposed. Exposed is nothing but all threads are so given to CPU to execute. So we are not restricting anything. So every thread, all 100 threads are allocated to all CPUs. That is a physical cores, right? So all threads, right? It has 25, it has 25, it has 25, it has 25. So what will happen? I told you one at any point of time one thread has to execute, right? So one thread executing, another thread is executing, and here another thread is executing. So at any point of time only one thread will execute it, remaining 24 will be in the queue. Which queue? It will be in the ready queue. It is available to run on the CPU. Again, like this is all completely a Windows CPU. Let's consider physical CPU, right? So 24 threads has to wait, 24 threads, every thread has to wait, all other threads has to wait. Once this is 4 millisecond is completed, then it will come out of CPU. It will write into the some point where it is context. The information will be written to the some portion, like some area. It will be written that context where it left the thread, and whatever thread which is left, it will be there in the. It will be at the end of this runnable queue. So that we will discuss about more. So it will be at the end of runnable queue. So total for 25, and whatever thread which is waiting, it will be going executing. So it keep on so doing this contexting, it keep on so running, and 4 milliseconds, every 4 milliseconds it should come out of CPU. Every time it has to write that information into the context switching and loading that context switching while executing the thread. It is kind of performance issues, right? Because we are doing every 4 milliseconds we are coming out of CPU, and all 24 threads has to wait, which is not doing anything. So these 24 threads are kind of blocking, right? So that to avoid this, main purpose is to avoid context switching. So we have introduced UMS, user mode scheduling. So we will be scheduling on our own mechanism, right? So we'll schedule our own designed to introduce, right? So probably it is already delayed, so mostly we will discuss this UMS and so SQL tomorrow, so that we will have a will not stop this going forward, right? So I'll stop here and we will discuss about UMS tomorrow, right? So any questions?
Yeah, Chandu, you have said the priority, right?
Hmm,
That priority setting.
correct.
So the priority setting is when I have read, it will leads to around 10 to from minus 10
Mhm.
locking process.
Okay.
So is it the same what you said? I mean, is it the related to CPU or else related to locking?
So priority, so which priority you are talking about? The thread
You
priority
have
or?
Yeah, you have showed some thread priority. Is it a thread priority or else the locking priority?
Okay. So when we talk about priority, it is a priority, like for example, let's consider your scenario. I mean, so I don't know what sense, but let's consider your scenario that you must have heard deadlocks, right? So deadlock,
Yes.
we will talk that deadlock later, but deadlock in a high level overview, let's say two or multiple threads executing, and one transaction or one session will be killed, right? Because of deadlock situation, and it will roll back its whatever it has done until that. So that is, you don't want that. You don't want that session to be killed, right? For example, let's consider that you have SQL job that is monitoring SQL health. Another query is SQL update transaction, right? SQL update transaction. And every time whenever deadlock happens, your update transaction is killing, right? If your update transaction has been killed, what will happen? It is interruption to your users, right? It is interruption and it will go for rollback and all. It takes longer. What I want, instead of this, I want this to be killed. How to decide that? So I can set the deadlock priority for this particular so execution or transaction or job, then this will be killed. So this will have a low priority and this will have a high priority. So in SQL Server, all are same priority, that is 7. So if you set the low priority, this is a normal priority. If you set the low priority, then it is kind of, so lower than 7. It can be either 6, 5, whatever priority level. Then what happen next time whenever deadlock situation occurs, instead of this, it will be killed this one. So instead of the so update transaction, it will be the job will be killed. This is okay, right? So this is just a monitoring of your health check. So this is okay to kill, but it should not kill this update transaction, so that you can set the deadlock priority of this. But whatever plus or minus 10 or 10,000 you mentioned, so I'm not sure, like so that uh, so we have around 32 priorities.
Okay.
So starting from 0 to 32, it will be allocated a range of priorities to threads, and that will be taken care based on that. For example, let's say in always on that we have something called leasing mechanism or lease timeout, that has so high kind of high priority, or OS threads. OS thread will definitely have high priority. That is kind of one example that we can consider, which has a high priority. So if you so you if you encountered, maybe you can just give a high level understanding what exactly the transaction wise you mentioned, so that I will check if it is something related to this.
Okay, sure, Chandu. So
Yeah.
I just so based on this priority, Windows scheduler
Hmm.
will assign a thread to particular CPU.
Correct. So correct. That is exactly meant to be. But based on the priority, that will be allocated to the CPUs. For example, let's say few threads which are highest priority, few threads which are low priority. High priority threads will be allocated first, and once those threads are completed, then low priority thread will be allocated next. In
Okay,
between,
thank you.
if we are executing few threads here, if you are executing few few threads are executing, if high priority threads are created and they wants to execute, then whatever thread which is currently running on the CPU will be come out of CPU, and it will allow high priority thread. That is what deadlock priority is meant to be.
Super, thank you. Thanks. I had a confusion actually. Locking plus the scheduler. So
Hmm.
now I got clear. Thank you.
Okay, cool. Right. So I mostly I'll stop here. So we will discuss UMS goals and all. So main part, like so why we need SQL OS, right? So how to restrict this context switching. So I told you that all. Uh, if we have 4 CPUs, and so we have 256 threads or 512 threads will be spawned based on the SQL Server and the number of processors, right? How SQL Server will handle, right? So how SQL Server will handle without any much performance issues. So how SQL will handle because of this SQL OS concept, we will talk more, so mostly tomorrow. Um, I will stop here. So if you have any questions, we will
Sure.
discuss, or we'll stop here. Yeah,
Okay. Okay.
cool. Any questions? I will stop recording here.